All right, here we go, everybody. Here is the unit notes for section 6.6. This is the second and last unit that we'll be dealing with in section 6 for this semester. And basically, what we're doing here is a lot of the same stuff we did in the last videos. We're basically just going to be graphing quadratics, but it's going to be a very different. It's going to be a bit of a different form. A lot of the stuff that we did in the last unit or the last section are basically going to be the same. There's just a few tweaks that we're going to do. So here is the Vertex Form kind of notes here. You can find this on your note sheet. You can find the PDF in the note sheet on Google Classroom. So basically the Vertex Form here is basically defined like this: y is equal to a times x minus h, all that squared, plus k. And then so from there there's a few examples, so a few things to go here. So and of course, if you want to pause at any time and just write this stuff down, you can. I'm just going to kind of briefly go over it. The a value, that stuff is still basically the same. Those rules are all the same, all right? If a is positive, then it's going to be, opens up. If a is negative, then it opens down. So basically, we're looking at the same stuff when it comes to the a value. Now, basically the difference between Vertex Form and the last one is that this time, it literally gives you the vertex form in terms of h and k here, okay? The h value inside here is the x value of your vertex, and the k value is the y value of your vertex. Now, the one thing that I need to make sure that we're keeping clear is x minus h right here, that the sign inside the parentheses is very important. Inside the parentheses here, you flip the sign. The k on the outside stays the same. All right, so again, I'll kind of write it over here. Inside parentheses equals change sign. Then the outside, you don't change the sign. So again, all right. So for example, like if you had like x minus 2 or something like that, then the value in the vertex would be a positive 2, not a negative 2. Okay. So again, kind of erase some of this. Kind of make sure it's a little bit better there. See a little bit better there. But again, h value is the x value of your vertex. K is the y value of your vertex. Now, with axis of symmetry, we don't use what we used in our last unit, the negative b over 2a, because it gives you whatever the h value, let me back up. Because it gives you what the vertex is, all we really need to do is look for that x value of the vertex. And basically, the axis of symmetry is going to equal whatever that h value is on your vertex, okay? Now, the other thing that changes here the other component that changes that we need to find is y-intercepts. And the way that changes is that we just plug in 0 for x. It's basically as simple as that, all right? You plug in 0 for x right here, and you basically just simplify the equation down depending on, or just to simplify it down to find that y-intercept. Other than that, the rest of the stuff is the same. Domain and range, you basically still use it the same. You still use the same way. This time, it's actually a bit easier to find range. It's actually a bit more straightforward because it gives us the vertex. And again, we want to use the y value of our vertex in our range. Okay. So let's go ahead and graph this equation here. All right, and I'll kind of try to use the same way that I did with the last section there. Okay, so we got our equation y is equal to 1/2 times x plus 2 squared minus 2. And again, let's go through our questions here. I look at my a value first. It is a positive number, so I know that it opens up. And because I know it opens up like this, there is a minimum value at the bottom right there, so it opens up with a minimum value. I usually skip axis of symmetry. When dealing with vertex form, I usually list out the vertex first and then find the axis of symmetry. So our vertex, we've already looked at our a value. We're looking at our now h value here and our k value there. I kind of label h and k. and my h value is 2. Now remember, it's inside the parentheses, inside these parentheses here, so I have to flip whatever this sign is. So it's plus 2, so when I put it as my x value of my vertex, it's going to be a negative 2. And then the k value that's on the outside of the parentheses, that stays the same. So this k value over here, stays as negative 2. All right, now because it gives us the vertex, axis of symmetry is essentially x equals the x value of our vertex, which is the negative 2. So it's going to be x equals negative 2. All right. Y-intercept, again, we're going to plug in 0, 0 for x. So I'm going to go over here and do that. I got 1/2. And then it's going to turn to 0 plus 2 squared minus 2. And if we simplify that down, that's going to give me 2 squared minus 2, which equals 4 times 1/2 minus 2, which technically is 2 minus 2, which is 0. Okay, so my y-intercept is 0. Domain and range, skip solutions. I'm going to graph it first. Domain, still the same as we had in the last section, always negative infinity to infinity. Range, again, what I'm looking for with the range, up/down, and then y value of vertex. All right, so first, up or down? Opens up, okay? If I know that it opens up, I'm going to have a positive infinity with a parenthesis, always a parenthesis around the infinity. Comma, all right, gotten that done. Find the y value of my vertex. Y value of my vertex is right here, which is negative 2, so I'm going to write negative 2 with a bracket symbol, okay? So that's my range. Now let's go ahead and graph it out here, all right? You choose a color over here. And graphing is basically still the same process that we used in the last section, all right? We're going to put our vertex right in the middle here, negative 2, y value of negative 2. And then still the same process. I go up 2, so 1 and 0, and then down 2, negative 3 or negative 4, okay? And let's see, I got x equals 0 right here. I already have plugged in 0 for x, and I got out the value 0. So I'm going to put, for x equals 0, I get y equals 0. And then again, because I put the vertex in the middle here, this value here has to be the same as that value down there. So I put negative 4 and 0. So basically what that leaves me now is I need to plug in either negative 1 and negative 3. I'm going to go ahead and plug in negative 1. Let's see, do negative 1 plus 2 squared minus 2. Negative 1 plus 2 is equal to 1 squared, which, well, is just basically equal to 1. So I'm just going to erase that squared there. So negative 1 plus 2 is 1. 1 squared is 1 times 1/2 equals, well, basically 1/2 minus 2. That gets us a negative 1.5. So I'll plug it in here, negative 1.5. Again, because my vertex is in the middle, this has to be the same value as that. And there we go. And then from there, let's go ahead and graph my stuff, or graph my points. Negative 2 down here. I got 0, 0 here. Negative 4, 0 here, and then negative 1, negative 1.5. Let's see, negative 1 down to 1.5. It's about here, and then this one's right about there. And then we just graph it. And then the last thing that I need to look for are the solutions on the graph. And again, when I'm looking for that, I'm looking for the x-intercepts. Anything that crosses this horizontal line right here. And if I look, I have a crossing at negative 4 and at 0. So my solutions are going to be negative 4 and 0. All right. Okay, so that one is filled out. Let us fill out this next one here, okay? All right, so last example here. So, opens, first you right here, looking at this a value, excuse me. There is no number, so to speak, out front there, but I see that there's a negative sign out there. If there's that negative sign out there, that basically is, it's almost the same as having a negative 1 out in front. Just kind of rewriting it here. It's literally the same as this, okay? Now, that basically tells me that I have a negative number out front there, so my is going to open down, which tells me that I'm going to have a high max value all the way up here, all right? Which means I'm going to have a value of a max, all right? All right, so again, I'm going to skip axis of symmetry for right now, go to vertex. Let's see, I have an x minus 3 inside of my parentheses, but there's nothing on the outside that's being added or subtracted. And basically, whenever that happens, if I have nothing on the outside here, that basically tells me that it's plus 0. So for my y value, my vertex, it's just going to be 0. And then for my x value of my vertex here, it's whatever's inside the parenthesis. I have a minus 3, and then I flip the negative 3, and it turns into positive 3. All right. And then from there, I also graph and then from there, I can find my axis of symmetry. It's x equals the x value of my vertex, which is 3, so it's just x equals 3. Y-intercept, plug in 0 for x, go over down here. I'm just going to plug in a 0 right here for x, so it's going to be 0 minus 3 squared equals, I got a negative out front, negative 3 squared. Let's see, square the negative 3, that turns into a positive 9. Negative outside makes it a negative 9. So I get a negative 9 as an x-intercept. Domain and range. Again, skipping solutions for right now to do domain and range. Do this one right here. So domain, always negative infinity to infinity, never changes. Or even write the word always right there. Range, up or down, y value vertex. Two things I'm looking at there. And again, up is positive infinity, down is negative infinity. Look over here, it opens down, so I'm going to start off with the negative infinity that goes on the left side here. So negative infinity with the parenthesis. Oh, excuse me. And then I look at the y value of my vertex. It goes to y value is 0, so it's going to be comma 0 with a bracket. Not a great looking bracket there, but all right. So got all my stuff quickly figured out there. Now I'm going to go ahead and fill out my table. Middle chart, I have 3, 0. And then as I've done before, I'm going to, for my x values, just for my x values, not my y values, just for my x values, I'm going to go 2 down, 2 and 1, and then 2 up, 4 and 5. All right, so I'm going to just go ahead and start with the 1 here, plug in 1. So I got negative, I plug in 1 minus 3 squared. 1 minus 3 gives me negative 2 squared. Negative 2 squared is 4, but with that negative out front, it turns into a negative 4. All right. And then because, again, I have my vertex in the middle here, this y value here has to be the same as this y value down here. Has that symmetry. All right. So there's going to be negative 4 down there. And then for 2, I'm going to erase my work up here. Let's see. Nope, not that. And then for 2, I just plug in 2. So I got negative, and then 2 minus 3. Don't mind that. That's 3. Sorry about that. 2 minus 3 equals negative 1. Negative 1 squared is just 1, but with the negative outside, it turns into a negative 1. So plug in 2, you get negative 1. Remember, this one has to be equal to that one, so I'm going to put a negative 1. And then from there, we can go ahead and start to graph. So I plot 3, 0, which is right here. 2, negative 1, which is right there. 4, negative 1, which is right there. Go 1, negative 4 down there. And then 5, negative 4 right down there. And then technically my y-intercept is 9, so it's actually down here. So just go ahead and connect those dots right there. And we're looking for my solutions. Anything that crosses the x-intercept, the x-axis right here. Even though it doesn't technically cross, go from this side to this side, it touches right there at the 3 value, all right? That's basically what we call it bounces off, all right? So even though it doesn't cross, it still touches there, so that still counts as one of my solutions. But it's only going to be 3. It doesn't cross anywhere else. All right, those are the notes. Thank you.